I'm going to talk a little bit about the systems engineering approach. If you accept the SPaT challenge and your agency is going to deploy SPaT, we strongly recommend following a system engineering approach. So I'll do kind of an overview of what that is and focus then a little bit specifically on the concept of operation and system requirements documents. And then I'll talk a little bit about what we're doing here in Minnesota with the project we're working on, just as an example of some of these things. So before I do that, we'll talk a little bit about why, oops, pushed the wrong arrow. There you go. Why do we want to do a system engineering approach? And there's several reasons here. The first easy one is if you're using federal money, it's a requirement. But even if you don't have to do it, there's reasons that you would want to do it. Some of the best reasons have to do to make sure that your system meets the user needs. You don't want to put out a SPaT system and then have people that you think are going to use it come and say, why would we want one of these? So you need to work with this process makes you work with the users and understand their needs. Also helps you make sure you don't miss any needs. If you think of the system and everybody that's going to interact with it, sometimes you come across some needs that you might not have thought about. Maybe the maintenance people have some needs to be able to remotely monitor things or diagnostic aids. Maybe the traffic engineers need some logs and archives to do traffic studies and stuff that might not have been the first things you thought about, but this process helps you think of those things. Also helps document a common understanding of what you're trying to do. You want to make sure that all the people involved and any contractors or vendors you have are all on the same page what you're trying to accomplish, and this process helps with that. Helps you know how you should do testing. We'll see that in a little bit. If you're building a system that's going to require somebody to do some ongoing operations or maintenance, this process helps you think through that, who's going to do what. And it's especially valuable if you're doing a system like SPaT that most of us don't have a lot of experience with. Helps us think it through before we get too far into building it. So this is the system engineering V diagram. This is what many of you are familiar with it. Commonly used to describe the system engineering process. Actually, the webinar series kind of follows this flow of things. We're talking today about the concept of operation and system requirements. You see all the future webinars were about design, and we got some testing stuff at the end that's kind of following this flow of things. So I'm just going to step through this a little bit. I also want to point out there's a link highlighted at the bottom. That's the System Engineering Guidebook for ITS. It was put together by the FHWA in California, and it has a lot of detail about all of these different steps, and in the appendices there's some suggested content that you might want to have in these documents that is useful. So this is process goes through the whole life cycle of the project. Time starts in the top left there and works your way to the right. These could all have been just in a straight line, but by making it into a V, you can see how the steps on the right side of the V relate to related steps on the parallel level on the left side. So it's a useful document. So the first two things up at the top left, they're really your planning efforts, and those are things you went through to figure out that you're going to do a SPaT project. I won't talk too much about those. The concept of operations comes next, and that's when you're really getting into talking about the system. This is frequently called a CONOPS. And this system engineering process really has to do with your system. It will help you build the right system and build the system right. You also will need a project management plan that helps you with the project. It's going to have the scope of work and the budget and the schedule for everything that would complement this, and these tasks should be part of your project management plan. So the concept of operations is where you kind of step back a little bit from thinking about how you're going to build this system and make sure you've understood the needs. You want to know who's all the people or systems that are going to interact with it, and in what way do they need to interact with it, and a big outcome of the concept of operations is the user needs. And then we're going to get down to the system requirements, and that's where you kind of specifically spell out what was identified with the needs and what all has to be done to meet those needs. It's really what functions does the system have to do. So these first two steps, the CONOPS and the system requirements, are really identifying the need and not the solution. You may have 5 different designs of a system that could meet the requirements and implement what you had in your CONOPS. And so you want to try and keep the design details out of these documents. But then the next step is when you start to say how you're going to design it. So the high-level design is really a system architecture. You're going to identify here's all the major components of the system, how they work with each other and how they work with the outside world. For a SPaT project, one of your components in your system architecture is going to be a roadside unit, for example. And high-level design would show how that interacts with other components that's inside the system you're building. And then you have the detailed design. You said you needed a roadside unit. This is where you would write the specification for that roadside unit. You may have specifications for some software modules. You may have plans and specs for building some stuff in the field. All that's in the detailed design. And then down at the bottom of the V is where you actually go buy the stuff, develop the software, install stuff in the field, and kind of build it. And then when you're working your way back up the right side of the V here, this is where you're testing it all out, and it relates to the similar level on the left side. So in the detailed design, we wrote a spec for a roadside unit. We went out through our procurement process, and we got 100 of them, or in this case 20 of them, or however many you're doing. We want to make sure that the roadside unit meets the spec that we did. That's the unit testing. And then you're going to go up one. You're going to put all these components together, and then that testing is going to make sure that all the components do what they're supposed to do and interact the way that you designed it. And to this point, all the testing is against your design. But the next step up is going to be this system verification, and that's really acceptance testing, and that's where you're going to test against the system requirements to make sure not just that the system was what you designed, but that it meets what the requirements were. And then the next step up, system validation, we frequently call that evaluation. So if your CONOPS had, say, some red light violation warning in there and that we were doing with the hopes to reduce crashes at intersections, you might want to do an evaluation to see did we actually reduce crashes at intersections. Then you get up to the operations and maintenance, and for years that might be what you're doing, and undoubtedly you're eventually going to want to do some changes and upgrades. And finally, at the end of the life of the system, you either retire the system or replace it. So I want to talk a little bit more specifically just about 2 of these. The first is the concept of operations. And I would like to just read what it says in the System Engineering Guidebook about what the CONOPS is. It says the concept of operations is a description of how the system will be used. It is non-technical and presented from the viewpoints of the various stakeholders. This provides a bridge between the often vague needs that motivated the project to begin with and the specific technical requirements. So again, this is where you step back, and before you worry about how you're going to build the system, we want to make sure we're all on the same page as how the system's going to be used. And it's, again, from the point of view of the users and the stakeholders. So this shows some contents you might want to have in there. There's other things that go in here, but these are some of the big pieces, the scope and the background. And the system overview, this isn't really what's inside the system you're building. This is more of a context diagram. How does the system that you're building interact with users and with other systems? So this will show us who's all going to interact with the system and how. And from that, you'll be able to get some operational needs that you can document. And then from that, you come up with the concepts for what you're going to try to do. This could be what applications you're going to do, what functions, So for example, if you're trying to meet the SPaT challenge, you can do that just by broadcasting SPaT. But then if I take my boss out to show him, there's nothing to see. It's broadcasting SPaT, but he just has to believe me. So, or you may want to, say, get an onboard unit in a vehicle with some kind of a display that you'll be able to see what's being broadcast. If that's your concept, you want to make sure you put that in here. Or maybe you're going to do some applications. Maybe you're going to put some stuff in vehicles and demonstrate red light violation warning, or maybe a pedestrian in the crosswalk warning. So this is the value of the CONOPS. You have to think through all that and make sure what you actually want to do in your project and document that. That's what gets everybody on the same page. And then you're going to have some user-oriented operational descriptions. You know, what does this system do for the driver? What does it do, you know, for a pedestrian? That type of thing, where you explain it from the point of view of the users. And then finally, some operational scenarios. And this is kind of where you step through it step by step. How do the different people interact with this? This is going to happen, then that happens, and that happens. And all this is to just help everybody have the common understanding of what is it that we're trying to do. So I'm going to switch gears just a little. Oh wait, first I got to skip ahead here. The system requirements. Again, this is where you kind of put in specific terms the things that you came up with in the concept of operations. I'll read the thing from the guidebook for this also. So this is for the system requirements document. This document describes what the system is to do, the functional requirements, how well it is to perform, the performance requirements, and under what conditions, non-functional and performance requirements. This document does not define how the system is to be built. So a lot of times people want to, I've seen a lot of variety of CONOPS and requirements. Some of them don't even think of the users when they're talking about stakeholders. And when they talk about how it works, it's all about how the different parts of the system within it is going to work. And that, to me, is not really what's valuable in the CONOPS and the system requirements. We want kind of a functional thing. What does it have to do? And the next stages in the system engineering process will define how you're going to build it. But this lets you make sure you didn't overlook what it is you're trying to do. So you're going to have itemized requirements. You may want to put some verification methods in there, because you're going to use these requirements to do your acceptance testing. And so when you're writing the requirements, you might want to be thinking about how would you test that. Some of the requirements may be, for SPaT, for example, may be certain things that come out of the SAE J2735 document that was mentioned previously. So you might want to put those references in with your requirements. And you want to be able to trace it back to needs that you identified in the CONOPS. If you have requirements that don't have needs, then you have to wonder, is that requirement really needed? And if it's clear that it is, then you need to go back and see, did we miss something on our needs? So now is when I'm going to change gears. I'll talk a little bit about, oh, I forgot to do this. That was what I was just talking about. We can talk a little bit about what's some of the stuff that we're doing here in Minnesota. We're just at the beginning stages of our SPaT project. And so we have a consultant, WSP, on board to help us with some of these. And I just thought it might be useful to see some of the tasks we're asking to be done. Looking for the CONOPS to be done, the system requirements I just talked about. We're also looking for a data governance plan. We got to decide, do we want to, say, archive SPaT data? We also want to receive some basic safety messages. Do we want to archive that? Is there any privacy concerns? How long are we going to keep it? Who has access to it? That type of stuff. We're doing a system security plan. There's kind of two parts to that one. Doing the security that so people receiving the messages can trust the messages and know it came from the traffic signal and not from a computer science student sitting by the side of the road seeing if they can make cars stop. But then we also want to talk about the security of our network. We're hanging all these roadside units there. We want to make sure we don't compromise our network security. Then we're looking for a project deployment plan to actually go build this. Once we've gone through this process, what are all the tasks we need to do, the budget and the schedule associated with that, and then also help us with design and construction support. This is an example. We got our CONOPS, first draft of our CONOPS document. We haven't even incorporated first round of comments or anything, so this isn't intended to be the final version of anything. This is just so you can see what this might look like. So the shaded box in the middle is our connected corridor system, and you can see that we don't show how it works inside of that box, but we're showing all of the different users that are going to use it and what their interactions are going to be. And some of the users are people and some are other systems, as you can see on here. And from that you can come up with needs. This is just a short excerpt out of some of our needs. You can see on the left it says what's the challenge you're trying to address, and then itemizes the needs, and they're numbered so you can refer back to them in other parts of the process. And then we wanted to identify what applications we're going to do to meet that. So we decided we're going to do the SPaT broadcast. We're also going to do a vehicle pedestrian intersection conflict warning, basically pedestrian in the crosswalk, working with our transit people also. And then we're going to do snowplow signal priority. We're going to do connected vehicle data management, where we can receive some basic safety messages and figure out, what can we do for figuring out traffic information, other things from that. We're planning to work with some third-party traffic signal data providers. There's several companies that have different ways of getting SPaT-like data and getting it into vehicles other than DSRC, and we'd like to be able to work with that. And then mobile work zone warning system, which would include like a snowplow ahead warning, and if we have a moving maintenance work zone, that we'd be able to provide warnings for that. This is an example. You don't have to see what's in it. This is one long table in the document. It's our scenarios, and I broke it into 3 pieces just to fit it on a slide. And the middle one, basically, that's where you have the steps. Here's what's going to happen first in this. This was the vehicle pedestrian intersection conflict warning. So this said, here's what's going to happen, with the driver, with the pedestrian, and what the system is going to do, steps through the steps. So that's just an example of what that might look like for some of the things that we were talking about. So that's just a summary. I went through the system engineering V diagram. Remind you again, there's that link if you want to see the guidebook. And then Dean Dieter